So let's begin looking at these problems dealing with light. The first problem we have is finding the frequency of yellow light where we are given a wavelength of 54 nanometers. To solve this problem, if you go back and you look at the equations you have, you are going to use the formula frequency equals speed of light divided by wavelength, and then you'll get your answer. When we look at number 2, we're looking at finding the distance to the moon. Now notice as you read the problem, it says that the time it takes to go to the moon and back to the earth is 2.486 seconds. So we need to know the time it takes to go from the earth to the moon, and that's going to be half of that time. So 2.486 seconds divided by 2, that's going to give us the time it took to go from the earth back to just the moon. And so to find this, we'll take that distance for that one-way trip times the speed of light, and then you will have the distance from the earth to the moon. Number three, we're looking at the inverse square law, and the inverse square law is a new law that we're looking at. This law states that the intensity of light is inversely proportional to the square of the distance. So what this means is that as the distance from the light source increases, the intensity of the light is equal to the value multiplied by 1 over the distance squared. So in order to solve this problem, what we're going to do is we're going to look at the problem and see that the lamp was moved from 40 centimeters to 160 centimeters. So we've got to get that difference in that distance. So we're going to put 1 over 160 divided by 40 and then square that, and that'll give us the answer. Now on problem number 4, we're looking at what is the illumination on the surface 4 meters below a 100-watt lamp that emits a luminous flux of 1075. So the first thing we're going to do is we're going to be using some new formulas, some new units. And so we're going to be looking at units of candela and foot candela. And so we need to, before we solve the problem, do some conversions. We need to take the radius that's 4 meters, we need to convert that over to feet. We also need to take the 1075 luminous flux, and we need to convert that to candela. And the way we do that is you take your luminous flux divided by 4 pi. That will give us the candela. In order for us to find the illumination on the surface, we're going to now take our candela and divide that by our feet squared. And the answer there will be in units of foot candela. When you do this, you should get an answer of 0.496 if you did all of your conversions correctly. Now some standards for you. 1 meter equals 3.28 feet. 1 foot candela equals 1 lux. Now for number 5, again, what we're going to need to do is take our luminous flux of 2275. We need to convert that over to our candela by dividing that by 4 pi. We need to take each of the distances that are in the chart that are in meters, we need to convert those over to feet. And then to find our illumination, we will then go back and we'll take our candela divided by our radius squared.